This is the video for the unit test review for graphing polynomials, problems 1, 2, and 3. And on our first three problems, what we're doing on this review is we want to use the polynomials and or the graph to identify the different features of the graphs. And first of all, standard form. Remember, standard form means that we need to have our equation in descending order. So that means our highest exponent is going to be the value here first. And our highest exponent is 9x cubed. Then our next highest is minus 7x squared. Our next highest is minus the 6x. And then lastly, we have the constant of the plus 13. Once we put it in this format, it's a little bit easier to identify the fact that the degree of this polynomial is the highest exponent in here, which is 3. And when we identify that fact, we know that degree 3 means that we're working with a cubic function. The degree also determines how many roots that we can have. And since our degree is 3, we're going to have the same amount of roots, which is also 3. The maximum number of turning points, we have 1 turning point less than the degree, which is 2. And finally, to determine our end behavior, what we do is we look at the leading coefficient. And the leading coefficient in this graph happens to be the 9. It's the number in front of the x squared term, and 9 happens to be positive. And when we're looking at our end behavior and we're not using our calculator to figure it out, what we know is that our graph to the far right is going to end up going towards positive infinity. So as x approaches infinity, here at the very bottom of this problem, as x approaches positive infinity, y is also going to approach positive infinity because our leading coefficient is positive. This is a cubic function, and to the third power is an odd number. That means that our end behaviors act then in opposite directions. So our other direction is when x approaches negative infinity, we are going to, y is also going to approach negative infinity. On problem number 2, the same idea. Highest degree term goes first. In this particular problem, negative x to the 4th is the highest degree term. And from there, we can identify the fact that our highest degree is 4. The classification for a 4th degree polynomial is called a quartic. And since our degree is 4, the number of roots that we have is also 4. Our turning points are 1 turning point less than the degree, so we have 3. And on this particular problem, we have a leading coefficient of x to the 4th, but it has a negative in front of it, so it's going to be a negative leading coefficient. Which means when we finish, as x approaches positive infinity, our y is going to approach negative infinity. We're going to go in the same direction as our leading coefficients, sign. Well, the degree is 4, and 4 is an even number. And so for even functions, what happens is that their end behavior goes in the same direction. And since we're going to finish with y approaches negative infinity, we're also going to start with y approaches negative infinity. As we switch over to a picture of a graph here, the number of x-intercepts, and in this particular problem, we have an x-intercept here, we have an x-intercept here, and we have an x-intercept there. There's 3 of them. In terms of turning points, we have a turning point here, we have a turning point here, and we have a turning point there. Remember that turning points occur when our graph changes direction. It has to change direction, but we happen to have 3 turning points. And we're going to go and think about this the same way. Remember that the number of turning points is 1 less than the degree of the function. So since we have 3 turning points, that number is 1 less than our degree. So our potential degree is 4. Our leading coefficient, as we look to the far right on the graph, our graph is going up to positive infinity. So since infinity is positive, our leading coefficient is also going to be positive. And again, we can look at this. We just said, as we look to the right, our graph, let me go back here. As x approaches negative infinity, so we're going left on our graph. What's happening to our graph is it's going up to positive infinity. As x approaches positive infinity, so if we start at the origin and go right, our graph again is also going up towards positive infinity.